Hello everyone, I am Balaji Rao. Welcome to BR Max class. Till now, we learned 3 exercises in Sets chapter. This video is about theory part related to 4th exercise and 4th exercise complete solutions. In this 4th exercise theory, we will learn operations on sets. We will learn how to calculate union of sets, how to calculate A union B, how to identify A union B in Venn diagram, and properties of union of sets. In the same way, how to calculate intersection of sets, difference of sets, all those things we are going to learn in this class. Without much delay, let's begin the class. In this class, we will learn about operations on sets. First operation is union of two sets. First, we will learn how union of two sets is defined. The union of two sets A comma B. Union of two sets A comma B is denoted by A union B. Look here, how we read this as? We read it as A union B. And how it is defined? A union B is defined as all the elements which are either in A or in B or in both A and B. That means A union B contains all the elements which present in either A or in B or in both A and B. We'll try to understand this with an example. You observe here, I consider two sets A, B. Now we need to calculate A union B. How A union B is defined? A union B is defined as all the elements which are either in A or in B or in both A and B. You observe one is there in A, so we will write here. If the element present in A or present in B, then it will be in A union B. 2 is there in A, so it comes in A union B. 3 is there in A, so it comes in A union B. You observe 4 is there in both A and B. Elements which are present either in A or in B are in both A and B. So even though 4 is there in both the sets, it comes in A union B. See 5 is present in B, so it present either in A or in B. Next 6. So in this way we will calculate A union B. Now we will learn very important note related to union of sets. We will try to understand what is A union B in Venn diagram. Which zone is known as A union B in this Venn diagram? You observe this first circle is set A, second circle is set B. Where is the zone which is A union B? If you observe in this diagram, total 4 parts are there. This is first part, this is second part, and this is third part, and other than these circles outside is the fourth part. Please try to understand. First part, second part, third part, fourth part. What is the fourth part? Other than these circles, what is there in this rectangle box other than this area? That is the fourth part. What is A union B? A union B is A union B contains all the elements which are either in A or in B or in both A and B. So the part 1, 2, 3 will be A union B. You try to understand this zone 1 and this zone 2 and this zone, this full zone. So this full is A union B. The part 1, part 2, part 3. This full zone is what? This is A union B. So the shaded part is the region of A union B. Now second important point related to union of sets. How we represent union of sets in set builder form. How we represent union of two sets in set builder form. X is the element present in A union B such that we write it as X belongs to A or X belongs to B. A union B in set builder form we can write like this: X belongs to A or X belongs to B. Third point, A union A. When we calculate A union A, what you will get? Can you guess what we will get? A union A. A union A is A only. Fourth important point. What you will say about A union B and B union A? Are they equal or they are not equal? What you say about A union B and B union A? Is A union B is same as B union A? What is B union A? B union A is the set which contains the elements which are present in B or in A or in both A and B. So here we can easily understand that in sets A union B is same as B union A. When we union with universal set, when we do union with universal set, A union universal set, which set we will get? We know that universal set is the set which contains all the sets or elements under consideration. So as universal set is the bigger set, when we do the union, bigger set will be the answer. So A union universal set is universal set. A union null set. Null set is empty set which consists no element. In these two sets, which set is the bigger set? A is the bigger set. So when we do the union, we will get bigger set. So A union empty set is A. In sets, associative law holds good with respect to union. A union B union C is same as A union B union C. You need to remember these points which will be useful while solving the problems. A union B union C is same as A union B union C. This is known as associative law with respect to union of sets. Last point. If A is subset of B, that means all the elements present in A are present in B, then what is A union B? Here you need to observe one thing. In A and B, which set is the bigger set? A is subset of B means all the elements present in A are present in B. Here we can easily understand that B is the bigger set. So when we do their union, we will get the bigger set. So A union B is B. So this is all about union of two sets. Next, we will learn intersection of two sets. Next, 14th synopsis is intersection of two sets. What is intersection of two sets? Intersection of two sets A comma B is denoted by A intersection B. Like this. How we read it as? A intersection B. Intersection of two sets A comma B is denoted by A intersection B and is defined as all the elements which are present in both A and B. It is not like union of sets. What is about union of sets? All the elements which are present in A or in B or in both A and B. But here in intersection of sets, we will consider the elements which are present in both A and B. We can understand this with an example easily. Here you observe two sets are there, A and B. A intersection B. What is A intersection B? How it is defined? All the elements which are present in both A and B. You observe the elements which is present in both A as well as in B also. One is there in A, one is not in B. 2 is there in A but it is not in B. 3 is there in A but it is not in B. You observe 4 is there in A and 4 is present in B also. So what are the elements which are common in both A and B that comes in A intersection of B? Is there any other element which is common in both? No. 4 is the only element which is present in both A and B. So A intersection B is the set 4, singleton set 4 you will get. Now we will try to understand what is intersection of sets more clearly by using Venn diagram. You observe here I consider two sets A and B, and this box we treat it as universal set. If you observe this box, total 4 parts are there in this. This first part, and this is the second part, and this is the third part. Other than these circles, whatever the remaining part is there, that is the fourth part. Now in this diagram, which zone is known as intersection of two sets? What is intersection of two sets? All the elements which are present in both A and B. You identify the elements which are present in both A and B. You see here, this is the zone, this zone present in A and this zone present in B also. Please try to understand. This is the zone which is present in A and which is present in B. That means second part is the intersection of two sets in this Venn diagram. Now, second important point, how we write A intersection B in set builder form. X is an element which is present in A intersection B such that X belongs to A and X belongs to B. In union, what we written? A union B is written as X belongs to A or X belongs to B. When we calculate A intersection A, what we will get? When we calculate A intersection A, we will get A only. You can observe that when we calculated A union A, at that time also we got A. When we do A intersection A, then also we will get A. Okay. Next, fourth point. What you can say about A intersection B and B intersection A? Is A intersection B is same as B intersection A? What you will say about A intersection B and B intersection A? A intersection B means all the elements which are present in both A and B. B intersection A means all the elements which are present in both A and B. We can easily understand that those two are equal. A intersection B is same as B intersection A. A intersection null set. Here you try to remember this. When we do union of two sets, we will get the bigger set. When we do intersection of two sets, we will get the smaller set. Here A is a set and phi is the empty set. We know that empty set is subset of every set. In these two sets, which set is smaller? So intersection of these two is empty set. A intersection empty set is empty set. A intersection universal set. Universal set is the set which consists all the sets or elements under consideration. In these two sets, which one is the smaller set? Obviously, the set A is the smaller set compared to universal set. When we do the intersection, we will get the smaller set only. Okay, so A intersection universal set is A only. What about associative law with respect to intersection? With respect to intersection, associative law holds good. That is, A intersection B intersection C is same as A intersection B intersection C. Associative law holds good with respect to intersection. We know that associative law holds good with respect to union also. Last point in intersection of sets. A is subset of B. Then what you will say about A intersection B? If A is subset of B, then which set is the smaller set? If A is subset of B, A is the smaller set. When we do the intersection, we will get the smaller set only. You remember, when we do their union, in case if we write about union, A union B, we will get the bigger set. If A is subset of B, B is the bigger set. When we do their union, we will get bigger set. When we do their intersection, we will get the smaller set. This is just a trick to remember these formulas. I hope you understand about intersection of two sets. Now, 15th synopsis is disjoint sets. Two sets A comma B are said to be disjoint if A intersection B is null set. That means if no element is common in both the sets, then we say that those two sets are disjoint. We will try to understand this with an example. I will consider a set A like this: 2, 4, 6, 8. And the set B is like this: 1, 3, 5. Are these two sets are disjoint? When we say two sets are disjoint, when we calculate their intersection, if their intersection is null set, then we say that the sets are disjoint. Calculate A intersection B. How we will calculate A intersection B? The elements which are common in both A and B. You identify any common element present in both A and B. There is no element common in both A and B. Here A intersection B is a null set. So what we say, therefore the sets A comma B are disjoint. Therefore, the sets A comma B are disjoint. The difference of two sets A comma B is denoted by like this, A minus B, like this, or A by B. What it is a notation of difference of two sets. Generally, we use this notation. Difference of two sets A comma B is denoted by A minus B. And A minus B is defined as all the elements present in A but not in B. What is A minus B? A minus B is defined as all the elements which are present in A but not in B. We will try to understand this with an example. You observe here, I consider two sets A and B. And what is A minus B? A minus B means all the elements which are present in A but not in B. You observe here, this is the element present in A but it is not present in B. Now you come to the second, B. B is element present in A. B is in set B? No. So we'll write like this. Now what about C? C is element present in A. It is present in B also. But what is A minus B? All the elements present in A but not in B. Okay. So here D is present in A. D is present in B also. So A and B are the only elements which are present in A but not in B. I hope you understand how we calculate A minus B. Now we will try to understand this more clearly with Venn diagram. Okay, you observe here, I consider the sets A and B. A minus B, I need to identify in this Venn diagram where is the region A minus B. What is A minus B? A minus B means the elements present in A but not in B. You observe this is the zone which elements present in A but not in B. Please try to understand. So you observe here this shaded region. What is this shaded region? This shaded region is A but not B. This shaded region is A but not B. So what is A minus B? All the elements present in A but not in B. Okay. Now second point, how we write A minus B in set builder form. A minus B is a set which contains an element X such that X present in A and X does not belongs to set B. X is in set A but not in B. So the set A minus B in set builder form we will write like this. Now third point in this difference of two sets, A minus B and B minus A. What you will say about these two sets? A minus B is same as B minus A. A minus B means elements present in A but not in B. B minus A means elements present in B but not in A. You observe this shaded part is A minus B. Similarly, if you observe this part, please observe here this part. This part is B minus A. Are these two are equal? No, they are different. A minus B is not equal to B minus A. You try to understand. In previous class, we learned A union B is same as B union A. A intersection B is same as B intersection A. Whereas it comes to difference between two sets, A minus B is not equal to B minus A. Now fourth point, A minus B intersection B minus A. Where is the zone B minus A? What is this shaded part? This shaded part is B minus A. This shaded part is B minus A. When it comes to their intersection, what are the elements which are common in both A minus B and B minus A? You can observe the sets A minus B and B minus A both are disjoint. There is no element common in both these A minus B and B minus A. So A minus B intersection B minus A is null set. Now fifth point, you can observe here A minus B and A. If we consider A minus B, this is A minus B. Is A minus B is subset of A? All the elements present in A minus B are present in A. We can easily understand this. You observe this is set A. This is A minus B. All the elements present in A minus B are present in A or not? Yes. So A minus B is subset of A. Similarly, what you say about B minus A? What you will say about B minus A and set B? B minus A, all the elements present in B minus A are present in B? Yes, of course. So B minus A is subset of B. Now sixth point in this difference of sets. What is A minus null set? A minus null set means all the elements present in A but not in null set. All the elements present in A minus null set is A. It can be understood very easily. 7th point, A minus A. What is A minus A? All the elements present in A but not in A. Is it possible? All the elements present in A but not in A. What is difference between A and A? A minus A is the null set. So A minus A is null set. Symmetric difference of two sets. How the symmetric difference of two sets is defined? The symmetric difference of two sets A comma B is denoted by A delta B. You please observe here, the symmetric difference of two sets A comma B is denoted like this, A delta B. In some books they'll denote the symmetric difference between two sets like this also. And how the symmetric difference of two sets is defined? It is defined as all the elements which are present in A are in B but not in both. Try to understand this carefully. All the elements which are present in A are present in B but not in both. We'll try to understand this by using Venn diagram. You observe here, I consider two sets A and B. What is this shaded part? You can observe here, this both the circles is nothing but A union B. What is this full part? This full part is A union B. But you observe the second part, that is intersection of both the sets. This is A intersection B. Please observe this area. A intersection B. From A union B, if we remove A intersection B, then we will get this shaded part. Please try to understand. A delta B is nothing but A union B. From A union B, if you remove A intersection B, all the elements present in A union B but not A intersection B. That means all the elements present in A are in B but not in both. Try to understand. Whatever the shaded part is there here, this part plus this part, this is symmetric difference between two sets. Here symmetric difference between two sets is defined like this also. See, A minus B, we know that just now we learned this shaded region is A minus B, this shaded region is B minus A. When we do their union, then also we are getting symmetric difference of two sets. So in this Venn diagram, the shaded part is the symmetric difference between two sets, right? Now we'll try to understand this more clearly with an example. See, here two sets are there. Set A is 1, 2, 3, 4, 5. Set B is 1, 3, 5, 7, 9. A delta B is defined as A minus B union B minus A. Okay. A minus B, all the elements present in A but not in B. 2 is present in A but not in B. 4 is present in A but not in B. So what you will get this A minus B? A minus B is the set 2, 4 union. What about B minus A? All the elements present in B but not in A. You see here, 7 is present in B but not in A. 9 is present in B but not in A. So here you will get 7, 9. So when you do their union, what you will get? You will get 2, 4, 7, 9. Exercise number 1.4 solutions. You observe this first question. What they are asking? Find the union of each of the following pair of sets. They given, you observe the first bit, they given two sets X, Y. They are asking union of these two sets. Like that, we need to calculate union of given pair of sets. Actually, in fifth question they given like this. Find the intersection of each pair of sets of question number 1 above. So what I'll do here, this first question, fifth question, I'll try to do at a time. That means for this first bit, I'll calculate X union Y as well as X intersection Y. Okay, let's see the first bit. Now, what is the first bit? You see, they given like this. The set X is like this and the set Y is like this. What they are asking us to calculate? They are asking us to calculate union of these two sets. We know that union of these two sets is denoted by X union Y. Okay, that equal to, what is X? 1, 3, 5 union. What is Y? The set Y is 1, 2, 3. Now, how the union of sets is defined? We learned this in the synopsis now. How the union of sets defined? the elements which are present in X, it comes to X union Y. The elements which are present in X, which comes to X union Y. The elements which are present in Y comes to X union Y. The elements which are present in both also comes in X union Y. What we learned, A union B means all the elements present in A are present in B are present in both. So here, if the element present in X, you look here, this is the element present in X. It comes in X union Y or not? Yes, it comes in X union Y. Now look here, 3 is the element present in X. Definitely it comes to X union Y. Even though it is present in both, it comes to X union Y. X union Y means all the elements present in X will be in X union Y. All the elements present in Y will be in X union Y. All the elements which are present in both also will be in X union Y. I hope you understand. So whatever element is there in X, that definitely comes to X union Y. You observe here, I'll try to write one order wise so that it looks good. Here 2 is there in Y. That 2 comes to X union Y? Yes. So 2. Next, 3 is there in X. It comes to X union Y? Yes. So 3. Next, 5. You observe here 5. 5 is there in X. So 5 comes here. So what you got here? You got 1, 2, 3, 5. So X union Y is what? X union Y is 1, 2, 3, 5. I hope you understand. The basic idea of X union Y means if the element present in X, it will present in X union Y. If the element present in Y, it present in X union Y. If the element present in both, then also it will be in X union Y. As I said, first question, fifth question we are doing at a time. I'll calculate X intersection Y also. X intersection Y. You write the elements of X 1, 3, 5 intersection. What are the elements of Y? 1, 2, 3. Now you observe the elements which are common in both. You look here, 1 is the element which is common in both, and you can observe that 3 is the element which is common in both. So what is X intersection Y? The elements which are present in both only present in X intersection Y. So here 1 is present in X, 1 is present in Y also. 3 is present in X, 3 is present in Y also. So the common elements will come in X intersection Y. So what is X intersection Y? X intersection Y is 1, 3. I hope you understand this, right? So for the first bit, we calculated X union Y as well as X intersection Y. Now we'll move to second bit. You observe here, the set is given like this. Set A is like this, AEIOU. And set B is given like this, ABC. What they are asking in the question? They are asking us to calculate A union B as well as A intersection B. First I'll write set A. AEIOU union. What is set B? Set B is ABC. Okay. How to calculate A union B? If the element present in A, definitely it will present in A union B. So what I'll write here? I'll write A. I just want to write a particular order. You see here, after A, B is there. B is present in set B. So B will be there in A union B. B comes here. Next, C. C is there in set B. That's why C comes to A union B. Next, D is not there. So next, E. E. E, yes. Next, I, yes. O, yes. U. So you can observe whatever the element you take in A union B. This is A union B now. Whatever element you take in this set, please try to understand. Whatever element you take in this set, that will be either in A or in B or in both. So that is the definition of A union B. Union of sets means the elements. A union B means what? The elements which are present in A are present in B or present in both. I hope you can understand this easily. Okay. In fifth question, they are asking intersection of sets now. So I'll calculate A intersection B. So what is set A? Set A is AEIOU. Okay. Intersection. What is set B? Set B is ABC. Okay. We need to calculate intersection of these two sets. Intersection means common elements. You look here, A is present in both the sets, and any other element is common in both? No. So A is the only element which is common in both. So obviously A intersection B is what? It is singleton set A. I hope you understand how to calculate A union B and A intersection B. Now we'll move to next question.
You observe this third bit, what they are asking. You see here, sets are not in roster method. Roster method means what? All the elements are listed like this. You see, this set is in which method? This is in roster method. All the elements are listed and separated by commas within the brackets. This is roster method. When it comes to this problem, the set is given in set builder form. This set is in set builder form. This set is also in set builder form. So how to calculate A union B, A intersection B? Easiest thing is, I'll write this set in roster form. I'll write this set in roster form, and this set also I'll write in roster form so that we can easily calculate. Okay, solution for this third bit. Set A. What is set A? I just want to write this set in roster form. What they are saying? X is a natural number. You know what are natural numbers? 1, 2, 3, 4, 5, 6. These are all the natural numbers. It is a natural number and multiple of 3. X is a natural number and multiple of 3. It's very simple. They are asking to write 3 table. 3 is a natural number. It's a multiple of 3. 6, 9, 12, 15, like that. This is infinite set. X is a natural number and multiple of 3. So set A is infinite set here. Note this point. Set A is infinite set. Okay. What about set B? Okay. Set B. What is set B? X says that X is a natural number less than 6. What are the natural numbers which are less than 6? What are the natural numbers which are less than 6? 1, 2, 3, 4, 5. These are the natural numbers, right? These are the natural numbers which are less than 6. Correct? These are the natural numbers less than 6. Now you observe, I written set A in roster form and set B also in roster form. Now I can easily calculate A union B as well as A intersection B. How to calculate A union B? If the element present in A, then definitely it present in A union B. If the element present in B, then definitely it present in A union B. If the element present in both, then also it present in A union B. So best thing is, first I'll write all the elements of set B. 1, 2, 3, 4, 5. These elements will be there in set A union B or not? Yes. Because these are the elements present in set B, these elements definitely present in A union B. After this, whatever numbers are there, you observe set A. 3 already written. Okay, 6. 6 not yet listed. I'll write 6. Why I am writing 6 here? Because 6 is present in A. Next, after 6, next what we'll write? 9. Why I written 9 here? Because 9 is present in A. If 9 is present in A, definitely it will present in A union B. Next what? After 9? 12. After that what? 15. After that what? 18. Like that it continues. So here A union B is a infinite set. I hope you understand this without any confusion. Right? Very simple thing is, you observe the definition of A union B. What is the definition of A union B? All the elements present in A are present in B are present in both. Simple thing. In this set, whatever the element is there, that will be in either set A or set B or both. Okay. So as per the fifth question, we need to calculate A intersection B also. No? So I'll calculate A intersection B. A intersection B means the elements which are common in both. Look here, 3 is present in A, 3 is present in B also. Right? Any other element common in both the sets? Any other element common in both the sets? I don't think so. So 3 is the only element which is common in both. So I can write like this. A intersection B is like this. Singleton set 3. I hope you understand how to calculate A union B and A intersection B. Actually, these are very easy problems. Only the thing is, you need to identify how we are calculating A union B, how we are calculating A intersection B. Okay. Now, you observe this fourth bit. What they are asking. X says that X is a natural number and 1 less than X less than or equal to 6. What to do in this problem? We need to calculate A union B as well as A intersection B. The only problem we have is, this is in set builder form. If I write this set in roster method means all the elements are listed separated by commas like that, then I can easily calculate A union B, A intersection B. So what I'll do, I'll write given sets in roster form. Okay. How to write? X says that X is a natural number. You know what are natural numbers? 1, 2, 3, 4 and so on. These are all the natural numbers. And see this one, in intervals we learn about these things. This notation is there now. In intervals we learn. So in between 1 and 6, what natural numbers are there? In between 1 and 6, what natural numbers are there? Just I'll write on in between 1 and 6. Here I'll mark 0, 1, 2, 3, 4, 5, 6. If I extend further, here I'll get a 7 also. Okay. You observe here as they given symbol like this, in between 1 and 6, what natural numbers are there? You just identify 1 and 6. 2 is a natural number which is in between 1 and 6. 3 is a natural number, 4 is a natural number, 5 is a natural number. These are the natural numbers in between 1 and 6 because they are saying x is a natural number. It must be a natural number and it must be in between 1 and 6. In last exercise we learned about intervals. When they given less than or equal to, that means at the time the 6 is also included. Right? So here 6 is also included. I hope you are understanding. Here 6 is also included. Got the point? So what are the natural number in between 1 and 6 means 2, 3, 4, 5. As they given less than or equal to, we will include 6 also. So what is set A here? Set A is 2, 3, 4, 5, 6. You observe here I not taken 1. In case here less than or equal to symbol is there. In case here less than or equal to symbol is there. Then at the time we need to write 1 also. But as per the question here strictly less than is there now. So we won't consider 1 even though it is a natural number. I hope you understand clearly how to write set A. They given set A in set builder form. I written this set in roster form. Okay. Now set B. What is set B? How it is? X says that x is a natural number. Okay, x is a natural number and x lies in between 6 and 10. Okay, same. We'll take the number line. In between 6 and 10 they are saying 5, 6, 7, 8, 9, 10 something like this. X is a natural number and this notation tells you that x is in between 6 and 10. You identify the natural numbers which are in between 6 and 10. In between 6 and 10, what natural numbers are there? 7, 8, 9. These are the natural numbers which are in between 6 and 10. Okay. You can observe here they are not given strictly, they given strictly less than. They are not given less than or equal to. If they give like this 6 also we need to include. If they give like this 10 also we need to include. But as per the question, in intervals we learned that 6 and 10 are not included. So what is set B here? Set B is 7, 8, 9. I hope you are understanding. Right. Now the point is set A, set B are there. Now we need to calculate A union B. How to calculate A union B? If the element present in A, that definitely present in A union B. If the element present in B, that definitely present in A union B. So I'll write first set A. 2, 3, 4, 5, 6. Okay. And then I'll write this set 7, 8, 9. 7, 8, 9. You observe once is there any element repeatedly written or not? No. 2, 3, 4, 5, 6, 7, 8, 9. So that's it. I hope you are understanding. The best thing is A union B means if I take any element in this set that will be either in set A or in set B or in both. Suppose if I take 6. 6 is there in this set. Definitely it will be. Suppose if I write 10 in this. If I write 10 in this. 10 is present in A union B means 10 must be in either A or in B or in both. You observe if I write 10 here. 10 is not there in this. 10 is not there in this also. So we cannot write like that. I hope you got the point. Now I need to calculate A intersection B. How to calculate A intersection B? Intersection means the elements which are common in both. You please observe. Is there any element common in both? There is no element common in both. Can understand there is no element common in both. So intersection of these two sets is what? It's a null set. No element is common. So we'll write like this. A intersection B is null set. So in this question they are asking to calculate union of sets as well as intersection of sets. Both we calculated. I hope you understand this bit. Now we'll move to last bit. You look here, set A is given like this 1, 2, 3. Set B is given like this. Here this 5 itself indicates it's a empty set. Empty set in roster form we'll write like this with brackets. We'll write like this with brackets with no element in it. Okay, what we need to calculate? We need to calculate A union B as well as A intersection B. Okay, A union B, set 1, 2, 3. Union B means null set. Okay, right. If the element present in A, that definitely present in A union B. If the element present in B, that definitely present in A union B. So what you will get here? Here you will get like this, 1, 2, 3. You please don't write like this. Don't write like this. This is not an element. This is a set actually. Okay. So actually A union B means it will be like this. I hope you understand. A union B. A intersection B. A intersection B means what? The elements which are common in both 1, 2, 3 intersection null set. Yes. What elements are common in both? In this set, there is no element. How we will find the common elements? So here the point is, there is no element common in both. So what you will get here? Here you will get null set. A intersection B is null set. So A union B is this and A intersection B is like this. In first question, they are asking us to calculate A union B as well as A intersection B. So both are done. So in fifth question, they are asking A intersection B. So fifth question also completed here only. So first question, fifth question completed. Now we will move to second question. Okay, you see the second question, they given like this. Set A equal to A comma B. Set A contains two elements. Okay, set B equal to A, B, C. What is this question? Is A is subset of B? This is the first question and they are asking what is A union B. Okay, let me do this. Is A is subset of B? When we say A is subset of B, all the elements present in set A are present in set B. Then we say that A is subset of B. Now you look here, all the elements present in A are present in B. You look, first set A is there, A is present in B, yes. B is there in set A, B is present in B, yes. So what we will write? Yes, yes, A is subset of B. Okay, and what further they are asking? What is A union B? Okay, what is A union B? A union B means what is set A comma B. Okay, union, what is set B? Set B is A comma B comma C. How to calculate A union B? Very simple. If the element present in A, definitely it present in A union B. So I'll write all the elements of set A first. Okay, now I'll write all the elements of set B. A already listed here. Okay, now B is there. B is also already listed. Now C. Okay, C. The point here, if I take any element in this set, that will be either in A or in B or in both. So this is A union B. Here I need to discuss one very important point. Look here, when A is subset of B, here A is subset of B. When A is subset of B, when I calculate A union B, I got set B only. I got set B only. So here I can write A union B as B because here I got, this is the answer. This is nothing but set B. So here what important point I am trying to say, when A is subset of B, A union B is B only. A union B is B only. At the same time, you can check that when A is subset of B, A intersection B is A. A intersection B is A. For example, here in this case only you see A is subset of B. When A is subset of B, A union B, we got it as B. I will calculate A intersection B. If I calculate A intersection B, I will get A. So here A intersection B is, first I will write set A intersection, next set B. Set B is what? A, B, C. Set B is A, B, C. Now you identify what are the elements common in both. A is present, B is present. Both are present. Okay. So intersection means we will get common elements, right? A comma B. What is this A comma B? What is this? This is set A. I hope you are understanding. When A is subset of B, listen please. When A is subset of B, A union B is what? When A is subset of B, A union B is B, A intersection B is A. Right? You need to remember this point. When A is subset of B, A union B is B, A intersection B is A. You observe here a Venn diagram is there. In these two sets are there. Set A as well as set B. You observe this is set A. Set A is smaller set and you observe this set B. Set B is bigger set. This itself indicates that A is subset of B. A is subset of B. What is A union B? Look here in the question only, third question you observe carefully. In the question only they given that A is subset of B. When A is subset of B, what is A union B? That is the question. See, when A is subset of B, all the elements present in A are present in B. So when we do the union, obviously bigger set you will get. Just think little bit. When A is subset of B, A union B means what? A union B means all the elements present in A and are all the elements present in B or all the elements present in both. So when I calculate A union B, I'll get bigger set here when A is subset of B. I hope you understand this point. So A union B is B. In case if they ask what is A intersection B, when A is subset of B, when we do A intersection B, we will get smaller set. Here they are asking only A union B. I am telling you what is A intersection B also. A intersection B means what? The elements which are present in both. You see here, this part is present in A, this part is present in B also. I hope you are getting the point. This part is present in A, this part is present in B also. This is the set which is common in both. That's why when A is subset of B, A intersection B is A. Or else, in simple words, you try to remember like this. When A is subset of B, when A is subset of B, here B is bigger set, B is bigger set, A is smaller set. Correct? You just remember like that. When A is subset of B, B is the bigger set, A is the smaller set. Obvious it is. For example, you see here, in this case, A is subset of B or not? Yes, A is subset of B. When A is subset of B, you look here, B is the bigger set, A is the smaller set. Correct? So, okay, when A is subset of B, B is the bigger set, A is the smaller set. When you do their union, you will get bigger set. When you do their intersection, then you will get smaller set. Right? So, all these things works when A is subset of B. So, you learn two important points. When A is subset of B, A union B is B, A intersection B is A. I hope you understand this. Now, see this fourth question. Fourth question is very easy question, but so many bits are there. I don't want to do all the bits. Listen, set A is given like this, 1, 2, 3, 4. Set B is given like this, 3, 4, 5, 6. Set C is given as 5, 6, 7, 8. Set D, 4 sets are given. Okay, find A union B, A union C, B union C, B union D, like that. Okay, I want you to try this A union B because we did so many problems. I want you to try A union C. Now I'll do this B union C. Third bit I'll do. Okay, third bit B union C. Okay, what is set B? Set B, you observe here, what is set B? 3, 4, 5, 6. Okay, set B is 3, 4, 5, 6. Okay, union. What is look here, B union C. Now what is set C? 5, 6, 7, 8. 5, 6, 7, 8. How to calculate B union C? In case if you confuse, best thing is write first set B. What is there here in set B? You write that set first. 3, 4, 5, 6. Okay. Next, you start writing this set. 5 already listed. No need to list again. 6 already listed. No need to list again. Next, 7, 8. That's it. B union C is over. This is B union C. With little bit of practice, you can enjoy these problems like anything. These are very easy actually. I want to do B union D also. This is the third bit. Third bit is over. Now, fourth bit. What is the fourth bit? The fourth bit is B union D. Okay, set B. What is set B? Set B is 3, 4, 5, 6. Okay, union. What is set D? Set D is 7, 8, 9, 10. Okay, what you want to calculate? You want to calculate B union D. Right. B union D. Very simple. First write set B, 3, 4, 5, 6. Now B union D. D is 7, 8, 9, 10. Na? Okay. First element what here? 7. 7 is already listed here? No. You write 7. 8 is already listed? No. 9 is already listed? No. 10 is already listed? No. That's it. So B union D is this. This is the answer for B union D. I hope you are understanding. Right. Now you see here 3 bits are there. A union B union C, A union B union D, B union C union D. I'll try to do any 1 or 2 bits. Okay. Fifth bit I'll do. What is the fifth bit? A union B union C. Fifth bit is A union B union C. Okay. What is set A? Observe the question. What is set A? Set A is 1, 2, 3, 4. Okay. Union. What is set B? Set B is 3, 4, 5, 6. Okay. Union C. Look here. A union B union C. First I written A. Next I written B. Now I am writing C. What is set C? Set C is 5, 6, 7, 8. Okay. How to calculate A union B union C? A union B union C means the elements A union B union C contains, if the element present in A, it comes to A union B union C. If the element present in B, it comes to A union B union C. If the element present in C, it comes to A union B union C. If common elements are there, those also comes to A union B union C. I believe that you are understanding what I am trying to say. Right. Now, simple thing is, first, what elements, these are the elements in set A. This definitely will be there in A union B union C. You just write 1, 2, 3, 4. Okay. Now, you observe these are the elements in set B. These elements definitely will be in A union B union C. But the point is, here 3 is there. 3 is already listed. No need to write it again. Here 4 is there. 4 is already listed. No need to write it again. 5, 6. Okay. Over. Now come to this. All the elements, these are the elements present in C. Definitely it will be in A union B union C. Now first we need to write 5. But 5 is already listed. No need to write it again. Here 6 is there. 6 is already listed here. So no need to write it again. So what we'll write? 7, 8. So what is A union B union C? Answer is 1, 2, 3, 4, 5, 6, 7, 8. I hope you are understanding. Okay, let me do one more bit here. That is the 7th bit. What is the 7th bit? Okay, 7th bit. What is 7th bit? B union C union D. Correct? B union C union D. Okay, let me take these sets so that we can easily write what is B union C union D. Okay, B union C union D. Right. Okay. See, first, what is set B? Observe what is set B. 3, 4, 5, 6. 3, 4, 5, 6. Okay. Union. What is set C? Set C is 5, 6, 7, 8. Okay. 5, 6, 7, 8. Okay. Union set D. What is set D? 7, 8, 9, 10. Okay. Clear. Right. Now, what they are asking to calculate, B union C union D. I written B union C union D. How to write? If the element present in B, definitely it present in B union C union D. So write all the elements of set B. 3, 4, 5, 6. Comma. If the element present in C, definitely it present in B union C union D. Right? So 5. 5 is already listed. 6 is already listed. So what you will get here? 7, 8. Now, if the element present in D, definitely it present in B union C union D. Here 7, 8 already listed here. So what you will get? You will get 9, 10. I hope you understand this solution. I just ask you to please do the homework problems in this. Right? So that you will get more clarity. In this 7 bits are there. I given 3 bits homework. You just try your own. These are very easy problems. So, till now 5 problems completed. Now we will move to 6th problem. Observe this question number 6. They given set A, set B, set C, set D. Then find the following. So you observe A intersection B, B intersection C, A intersection C, B intersection D. Like that these things are given. So what I will do first, you observe these 4 bits. In these 4 bits, I'll try to do any 2 bits. Okay. So because there are 2 sets intersection. So what I'll do, in last problem, you know how to calculate A intersection B. You please do this first bit. Now we'll do this second bit. What is second bit? B intersection C. Okay. What is set B? Set B is 7, 9, 11, 13 intersection. Here C is there, na? Set C. B intersection C we are calculating, right? Set C. What is set C? 11, 13, 15. Okay. B intersection. Intersection means common elements. 13 is common in both and 11 is also common in both. Next, any other element is common in both the sets? No. So what is B intersection C? B intersection C is 11, 13 because these are the elements which are common in both. Now you observe this fourth bit. You try this 4th bit. I'll do this 5th bit. Okay, 5th bit. Model wise we are doing B intersection D. Okay. What is set B? Set B is 7, 9, 11, 13 intersection set D. What is set D? 15, 17. Okay, you observe that. Is there any element common in both? Here 15 is there. 15 is not in first set. 17 is not in first set. So there is no element common in both the sets. In that case, we will write that their intersection is null set because there is no element in common. So we completed these 4 bits. I request you to please try this second bit and fourth bit. I request you to try this first bit and fourth bit. Okay. Now this third bit, A intersection C intersection D. Okay. Third bit, A intersection C intersection D. Okay. First you write set A. What is set A? 3, 5, 7, 9, 11. Okay. Intersection set C 7, 9, 11, 13. Intersection. What is C? 11, 13, 15. Okay. Intersection set D. What is set D? 15, 17. Now you identify the elements which are common in all 3 sets. For example, 15 you take. 15 is you look here, 11 is there. 11 is present in these 2 sets only, but 11 is not in this set. Is there any element which is common in all 3 sets? You please identify. Is there any element which is common in all 3? We can easily identify that there is no element which is common in all 3 sets. For example, if you can do this problem in another method also, you can do intersection of these 2. If you do intersection of these 2, what you will get? You will get 11. You will get 11, right? After that, you do intersection with this set, then also there is no common element, or else no need of doing all those things. You identify, is there any element which is common in all 3 sets? There is no element which is common in all 3 sets. So their intersection is null set. I hope you understand this. Before going to do further, first we will take these 4 sets. See this fourth bit, A intersection B union C. We will calculate this. How to calculate A intersection B union C? Here, whatever is there in brackets, we will calculate that first. Okay. So here this equal to first set A. What is set A? Set A is 3, 5, 7, 9, 11. Okay. Intersection. You look here, B union C. By this time, you are in a position to write B union C directly. B union C. B union C means the elements which are present in B as well as present in C are present in both. So I'll write B union C directly. Okay. How to write B union C? Here first write all the elements of B. 7, 9, 11, 13. Now you write all the elements of C. 11. 11 is already listed. 13. 13 already listed. 15. 15 is not listed. So this is B union C. I hope you understand. By this time you are in a position to write B union C directly. This is B union C. What happened? I written A intersection. Whatever is there in brackets, that you calculate. B union C. This is B union C. Now intersection. Intersection means what? Common elements. Is there any element which is common in both? You observe 9 is the element which is common in both. 7 is the element which is common in both. And 11 is the element which is common in both. Any other elements? Right. So what are the elements which are common in both? 7, 9, 11. So this is A intersection B union C. Okay. Next, 6th bit is over. You observe this 7th bit. You can do this very easily, right? I want you to try this 7th bit your own. Now you see this 8th bit. We will do this 8th bit. What is this 8th bit? A intersection B union D. Okay. This problem also similar to last problem. What I will calculate? First I will calculate B union D. Before that you write what is A. What is A? The set A is 3, 5, 7, 9, 11. Intersection B union D. What is B union D? You just try to write B union D directly. This is B, this is D. First write all the elements of B. 7, 9, 11, 13. Now you write all the elements of D. 15. 15 is already listed here? No. You write 15. Next 17. 17 already listed here? No. So you write 17. You know by this time, because from first problem onwards we are learning in examples also we learn how to calculate A union B, A intersection D, A intersection C, all those things, right? This is a simple thing only. Actual point is what? I calculated B union C, I written here. Now what to do? We need to do intersection of these two sets. Intersection means the elements which are common in both. Yes, identify the elements which are common in both. 11 is the element which is common in both. Next, 9 is the element which is common in both. 7 is the element which is common in both. Next, any other element is common? No. So what you will get here? Here the answer is 7, 9, 11. I hope you are understanding. 8th bit is completed. Now, you come to 9th bit. You see 9th bit, this is the 9th bit. Okay, 9th bit. 9th bit, we need to calculate A intersection B intersection B union C. What I'll do, whatever is there in brackets, that I'll calculate first. You can see here the sets A, B, C, D are written here, A, B, C, D. Okay, so first what I'll do, I'll calculate A intersection B. Okay, A intersection B. Calculate A intersection B. You observe here itself, A intersection B, the elements which are common in both A intersection B. 7, 9, 11. 7, 9, 11. These are the elements which are common in both. Correct? So I'll write directly here. What is A intersection B? A intersection B is 7, 9, 11. I hope you understand. Right. Now intersection B union C. Look here, B union C. This is set B. This is set C. B union C. Okay. B union C. Here what is there? 11, 13. 11. B union C. Na? B union C means here what elements are there in set B? 7, 9, 11, 13. All the elements of set B comes in B union C. When it comes to C, 11 is already listed here. 13 is also already listed here. So what you will get here? 15. Okay. So what we do? We do intersection of these two things. Yes, intersection of these two things. 7, 9. 7, 9, 11. 7, 9, 11. So what you will get here? This is 7, 9, 11. That's it. 7, 9, 11. I hope you are understanding. Now you see 10th bit of this problem. We'll calculate this one. What I'll do, first what is there in brackets, I'll calculate that first. A union D. Next I'll calculate B union C. Later I'll do intersection for these two sets. A union D, you can write directly. First you write all the elements of set A. Okay, write all the elements of set A. 3, 5, 7, 9, 11. Okay, now you write all the elements of set D. 15, 17. 15, 17 listed here? No. So you write those 15, 17. Okay. Intersection B union C. How to calculate B union C? First you list all the elements of B. 7, 9, 11, 13. B union C, na? You observe where is C? 11, 13, 15. 11, 13 already listed. So what you need to write? You need to write 15. Okay. Now B union C. B union C, we got it. Now we need to do intersection of these two sets. Identify the elements which are common in both. First 7. 7 is common in both. 9 is common in both. 11 is common in both. Next 15 is common in both. Right? Other than this, any other common elements? No. So what elements present in both? That comes in intersection 7, 9, 11, 15. With this question number 6 is completed. I hope you will do whatever the homework problems given in this. easily. Okay, now we'll move to question number 7. Okay, this is little tricky one, but actually it is easy only. You observe set A, they given in set builder form. Set B is also there in set builder form. Set C is also there in set builder form. Set D, it is also there in set builder form. We need to calculate these things. Okay, first thing what I'll do to make the things are simpler, I'll try to write these sets in roster form. Roster form means all the elements are listed separated by commas within the brackets. What is set A? X says that X is a natural number. What are the natural numbers? 1, 2, 3, 4, 5, like that. These are all natural numbers. Okay, set A I written. Set B. What is set B? Please observe set B. X is a even natural number. What are even natural numbers? 2, 4, 6, 8, like that. These are all even natural numbers. These are all infinite sets. Okay, set C. What is set C? Set C is X says that X is a odd natural number. What are odd natural numbers? 1, 3, 5, 7, 9, 11, like that. These are all odd natural numbers. Set D. What is set D? X says that X is a prime number. What are prime numbers? 2, 3, 5, 7, like that. This is also infinite set you will get. Okay, so here all 4 sets I written in roster form. Okay, first bit. What is the first bit they are asking in this question? They are asking to calculate A intersection B. Okay, while calculating A intersection B, what are the elements which are common in both? You observe. What are the elements which are common in both? Look here, 2 is common in both, 4 is common in both. In this set 6 is there, 6 is common in both. In this set 8 is there because it is a set of all natural numbers now. This set is set of all natural numbers now. In this 8 is there. So you can easily identify that A intersection B is set of all even numbers. 2, 4, 6, 8. 2, 4, 6, 8 and so on. Right? This is nothing but set B. A intersection B is B. Here I want to tell you one point here. We can do this problem in another way. If you observe this set A and B, observe these two sets please. Observe these two sets. Set B is a subset of A. All the elements present in set B are present in A, correct? Here I'll write here. B is subset of A. When B is subset of A, in in previous problems also we discussed. If B is subset of A is bigger set, B is smaller set. Okay, when we do B intersection A is same as A intersection B. B intersection A is same as A intersection B. When B is subset of A, B is smaller set. When we do intersection of these two sets, you will get smaller set only. That is B you will get. I hope you understand. That is what happened here. So, no need of doing all this procedure. When you realize that this B is subset of A intersection B is B only. Try to do this second bit. What is second bit? In second bit, they are asking A intersection C. You observe the sets A and C. Is A is subset of C or C is subset of A? All the elements present in C are present in A. I hope you are understanding. In this case, clearly we can say that C is subset of A. When C is subset of A is the bigger set, C is the smaller set. Okay, so when we do their intersection like A intersection C, when we do intersection, smaller set we will get. What is smaller set? C. When we do their union, you will get bigger set, right? So A intersection C is what directly you can say as C is subset of A intersection C is C only. In case if you have any doubts, you can check here. A intersection C, you identify the common elements. Okay, common element 1, 1, 3, 3, 5, 5. Whatever the elements present in this set, they all present in set A because set A is natural numbers. Here 7 is there. Here 7 is there. 7 will present in this. right? So obviously the set C only will come. No need of all these things. Directly we can say when A is subset of C, when C is subset of A intersection C is C only. I hope you got the point. Right. Now we'll move to third bit. What is third bit? Third bit is A intersection D. We need to calculate A intersection D. Can you say anything about this A intersection D? Is A is subset of D or something like that? A intersection D. This is set A. Okay. This is set D. Okay. Now clearly we can say that D is subset of A. For this, D is subset of A. Clearly D is subset of A. Here each prime number is a natural number. D is subset of A. Is that clear or not clear? D is subset of A. When D is subset of A, when we do their intersection, A intersection D, smaller set will come. Smaller set is what? D. So A intersection C is D. I hope you are understanding. Next, fourth bit. Fourth bit is what? Fourth bit is B intersection C. Here B intersection C, you observe these two. This is B, this is C. If B is set of all even natural numbers, C is set of all odd natural numbers. Can you find any element common? Can you find any element common in both? No, because these are all even natural numbers, these are all odd natural numbers. You won't find any element which is common in both. So B intersection C is null set. I hope you are understanding. Just little bit, try to think little bit. These are easy bits only. Okay, fifth bit. What is fifth bit? Fifth bit is B intersection D. Okay, B intersection D. You observe the set B and set D. Is there any element common in both? D is set of all prime numbers. D is set of all prime numbers. We know that in prime numbers, 2 is the only even prime number. Remaining all prime numbers are odd numbers only. Okay, so here you see B intersection D, here 2. 2 is the element which is common in both the sets. There is no other element common in both the sets. Here these are all even numbers, here these are all odd numbers. 2 is the only element which is even as well as prime. So when we do B intersection D, what is the common element in both? 2 is the common element in both. Okay, now we'll go to sixth bit. What is the sixth bit? Sixth bit is C intersection D. Okay, you observe set C and set D. C intersection D. You observe C intersection D. Is there any element common in C and D? Is there any element common in C and D? Okay, 3 is the element which is common in 3 is the element which is common in both. 5 is the element which is common in both. 7 is the element which is common in both. 11 is the element which is common in both, because D is set of all prime numbers. In this 9 won't come, right? Next 11 only will be there. So odd prime numbers, C intersection D is nothing but, I can write like this. X says that X is odd prime number. Odd prime number. We can write like this, right? I hope you understand this question number 7. Now we will move to question number 8. You observe what they are asking in this question. Which of the following pairs of sets are disjoint? Disjoint sets. We learn in the theory, when we say two sets are disjoint, suppose A comma B are two sets. When we say these two sets are disjoint, when their intersection is null set. When their intersection is null set, then we say that the sets A comma B are disjoint. When the sets A comma B, when we say the sets A comma B are disjoint, when A intersection B is null set, then we say that the sets are disjoint. Okay, so here we'll start the solution. To identify these two sets are disjoint or not, if both the sets are in roster form, it is easy to decide. Okay, so what I'll do, I'll try to write both the sets in roster form. First set, you observe this is already in roster form. Roster form means all the elements are listed separated by commas. 1, 2, 3, 4. Okay. Intersection. Because to say whether they are disjoint or not, I need to calculate intersection of given sets. Intersection of given sets is empty set, then we say that they are disjoint. Otherwise, we will say that they are not disjoint. Okay, now I'll write this second set. Actually, this set is given in set builder form. We'll write this set into roster form. What x is a natural number and x is in between 4 and 6. We know that in earlier problems also we used this notation. X is in between 4 and 6 means as less than or equal to is given 4, 5, 6. 4, 5, 6. Right? Actually in between 4 and 6, 5 is the only natural number. As they given less than or equal to here, we'll include 4 and 6. I hope you understand how to write this set in roster form. Okay, we already done these problems in earlier problems, right? Now you just calculate their intersection. Is there any element common? You see here 4 is the element which is common in both. Any other element? No. So here 4 is the element which is common in both. When we do their intersection, you will get set like this. This is not an empty set. Please observe this. This is not empty. When their intersection is empty set, then only we say that given pair of sets are disjoint. So here what I'll write, given pairs of sets are not disjoint. They are not disjoint. When we say they are disjoint, when we calculate their intersection, if we got empty set, then we say that they are disjoint. Here we got non-empty, that means they are not disjoint. Okay, now we will move to second bit. What is the second bit? Look here, AEIOU, and both the sets are in roster form only. So calculating this is very easy. AEIOU is the first set, intersection. Next, what is the second set? CDEF. Okay, you do the intersection of these two sets. What you will get? Intersection. Any element is common in both, you check it. E is the element which is common in both. Next, A, I, O, U, right. This is the element which is common in both. This is the element which is common in both. So when we do their intersection, I got like this. This is not an empty set. This is not an empty set which contains one element. So their intersection is non-empty. So what I can say? I can say that given pair of sets are not disjoint. I hope you got this point. Now we'll move to third bit. Okay, what is this third bit? Let's see this third bit. Third bit, x is even integer, x is odd integer. Okay, third bit, x is even integer. What are even integers? 2, 4, 6. You observe here, even integer set is there, na? That set intersection, odd integer is there, na? This one, odd integer, intersection, odd integer. When we do the intersection of these two, this contains all even numbers, this contains all odd numbers. Definitely there will be no common element in both. It can be understood because first set contains even integers, second set contains odd integers. When we do their intersection, you will get null set only. As you got their intersection is null set, what we can say? We can say that given pair of sets are disjoint. Given pair of sets are disjoint. Given pair of sets are disjoint. I hope you understand this 8th question, right? In case if you felt difficulty anywhere, you just this is a recorded video now. You can go back and you can check what clearly explained and what point you missed that causes you not understanding this point. Still any doubt is there, in comment section you can mention. Please observe this question number 9. Set A, set B, set C, set D. Like that 4 sets are there. Okay. So we need to calculate A minus B, A minus C, A minus D, B minus A, like that. In theory part, we learn how to calculate difference of sets. Okay, however, you see the first bit. What we need to calculate? We need to calculate A minus B. Okay, first I'll write set A. What is set A? 3, 6, 9, 12, 15, 18, 21 minus second set. Second set is what? 4, 8, 12, 16, 20. Here the point is A minus B means all the elements present in A but not in B. Try to understand. A minus B means all the elements present in A but not in B. To do this, we have a small trick. First, you identify the elements which are common in both. So, identify the elements which are common in both. Actually, 12 is the element which is common in both. Next, is there any element common in both? 12 is the only element which is common in both? Yes. So, what you will get here, we identified that 12 is the element which is common in both. You observe, other than 12, whatever the elements present in this set, other than 12, whatever the elements present in this set, they are in set A but not in B. Whereas when it comes to 12, 12 is A as well as in B. But as per the definition, A minus B means only A. The elements which are present only in A. But this is not only in A. This is present in B also. So we need to eliminate this 12. So what you will get? 3, 6, 9, 15, 18, 21. So this is A minus B. I hope you understand this, right? Now similarly, A minus C, A minus D, B minus A, I'll calculate A minus D. You see here, I'll calculate third bit. Third bit is A minus D. Look here, third bit, I'll calculate A minus D. Okay. First, I'll write set A. Write set A. What is set A? 3, 6, 9, 12, 15, 18, 21 minus set D. What is set D? Set D is 5, 10, 15, 20. Okay, A minus D. Here, first identify the elements which are common in both. Is there any element common in both? 15 is common in both. Next, there is no other element common in both. So, you write the other than 15, all the elements of first set you need to write. All the elements of first set, that is 3, 6, 9, 12, 18, 21. I hope you are understanding these bits. Now, I'll calculate this fifth bit. What is fifth bit? Fifth bit is C minus A. First, I'll write set C. What is set C? Here you try to understand, we are writing all the elements of first set only. A minus B means only A but not B. A minus D means only A but not D. C minus A means only C but not A. Okay, we'll write all the elements of C which are not in A. Okay, so here C minus A. What is C? C is like this: 2, 4, 6, 8, 10, 12, 14, 16. Okay, minus what is set A? Set A is 3, 6, 9, 12, 15, 18, 21. Okay, now you identify the elements which are common in both. 6 is the element which is common in both. Next, 12 is the element which is common in both. Next, 14, 16. You observe, is there any other element common in both? Okay. Now, other than these common elements, in first set what elements are there? That is C minus A. That elements belongs to only C but not in A. I hope you are understanding. So what is C minus A? C minus A is 2, 4, 8, 10, 14, 16. In this way, you can calculate all these bits very easily. Basic idea is you need to identify the pattern, in what pattern we are doing. A minus B means what? All the elements present in A only but not in B. So best method is to calculate A minus B. You write set A as well as set B. Identify the common elements. Now, other than common elements, in first set what elements are remaining, those you write. I hope you can do other problems very easily in this. Now, we'll move to 10th problem. You see, this is also similar to last problem only. Okay, 10th problem. What they are asking in the first bit? They are asking to calculate x minus y. Okay, write set x A, B, C, D. Okay, minus y. What is y? F, B, D, Z. Okay, so when we do their subtraction, the difference of two sets, how to calculate? First, identify the common elements. B is present in both, D is present in both. Next, is there any element common in both? Now, x minus y means the elements present in x only but not in y. So other than common elements, in first set what elements are remaining, that elements you need to write A, C. I hope you understand. So x minus y is A comma C. Now second bit. What is the second bit? Second bit is y minus x. Okay, write y. What is y? F, B, D, Z. Minus what is set x? Set x is A, B, C, D. Now you identify the common elements in both. B is the element which is common in both. D is the element which is common in both. So yeah, y minus x means you need to write all the elements of y which are not in x. So other than these common elements, what elements present in first set, that you write F comma G. I hope you are understanding. Now see the third bit. Third bit is very simple actually. What they are asking? They are asking x intersection y. Okay, what is x intersection y? X is A, B, C, D intersection. What is y? Y is F, B, D, Z. So here intersection of these two sets means the elements which are common in both. B is the element which is common in both. D is the element which is common in both. So intersection means what we will write? The intersection of sets means how you will write? The elements which are common in both. So what are the elements which are common in both? B, D. These are the elements which are common in both. This is very easy problem, right? I hope you understand this. Now you see this 11th question. What is 11th question? In 11th question, what they are asking, R is set of all real numbers. Okay, we know real numbers. Real numbers are in interval form. If I write minus infinity to plus infinity, these are the real numbers. Or else we can say like this also. Real numbers means union of rational plus irrational. Union of rational plus irrational. Irrational numbers is denoted like this also, R minus Q. The numbers which are not rational are called irrational numbers. Na? So what I want to say in this point, real numbers is nothing but union of rational and irrational numbers. R minus Q is also known as set of irrational numbers. From all real numbers, if you remove rational numbers, whatever remaining are there, they are all irrational. So R minus Q is set of all irrational. Try to understand. R is set of all real numbers. Q is set of all rational numbers. Then what is R minus Q? Very simple. Here the simple point is R is there here. R contains, what is R? Union of rational and irrational. R real numbers definition can be given like this. Real numbers means union of rational and irrational numbers. In this real numbers, rational numbers will be there, irrational numbers are also will be there. From the real numbers, if you remove rational numbers, whatever remaining are there, they are all irrational. It can be understood very easily. R minus Q itself indicates set of set of all irrational numbers. Set of all irrational numbers. The simple, this is the notation actually, r minus q. If q is the set of rational numbers, r minus q is set of all irrational numbers. Irrational numbers means you know na, root 2, root 5, root 11, such type of things are set of all irrational numbers. The numbers which are not rational are called irrational numbers. We will move to next question. This is very easy question. State whether each of the following statements is true or false. Justify your answer. Okay. You observe this first bit. What they are asking in the first bit. These two sets are given. They are disjoint. They are saying that 2, 3, 4, 5, 3, 6 are disjoint. These sets are disjoint. We need to decide whether it is true or false. When intersection of two sets is null set, then we say that given two sets are disjoint. Otherwise, we say that they are not disjoint. Okay, first bit, I'll take intersection of these two sets. 2, 3, 4, 5, intersection 3, 6. Okay, do the intersection of these two sets. Intersection of these two sets, you can observe 3 is the element which is common in both. When we do intersection of these two sets, you are getting 3. Is it a null set? No. This is a singleton set. It contains one element. As intersection of these two sets is not a null set, so what we can say, given this is false. They are asking just true or false. No? They are just asking to write true or false. So they are saying they are disjoint, but actually they are not disjoint. Given statement is false. Now come to the second bit. What they are asking, again they are saying that they are disjoint sets. I'll check. A, E, I, O, U, intersection A, B, C, D. I'll do their intersection. A is the element common in both. Next, any other element common is there? No. So when we do their intersection, what you are getting? You are getting singleton set A. Is it a empty set? No, it is not a empty set. So what they are saying in the question? In the question they are saying they are disjoint sets. They are asking us to decide true or false. Actually they are not disjoint because their intersection is not empty. So what we say here, this given statement is false. They are saying disjoint, but actually they are disjoint. They are not disjoint. Okay. Third bit. What they are asking in the third bit? Two sets are given. They are asking they are disjoint sets or not. To decide that, you just calculate their intersection. 2, 6, 10, 14. Intersection 3, 7, 11, 15. You observe, is there any element common in both? 2 is not in this. 6 is not in this. 10 is not in this. 14 is also not in this. So when we do intersection of these two sets, there is no element in common. So what I can say, there is no element in common means what I can say? I can say that this is disjoint sets. Intersection of these two sets is null set. If intersection of two sets is null set, we can say that they are disjoint sets. They are disjoint sets. That also that is same thing mentioned in question. So this statement is true. Similarly, you do this fourth bit. You observe here 2, 6, 10, 3, 7, 11. When we do their intersection, we will get empty set only. So obviously these sets are disjoint sets. So we can easily say that this statement is true. I want you to try that problem. With this, exercise number 1.4 is completed. I hope you understand this full exercise. This is a little lengthy exercise. Just once or twice practice is needed. What you will do while practicing these problems, if you felt any particular problem difficult, you keep something like P. P means practice is needed. When we do second time, you stress on the problem which causes you difficulty in that problem. And if you felt any difficulty, you always comment in comment section. I'll respond to your doubts.